Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. In the last lesson, we have learned the indicator strategy of super trend. And today in this lesson, we'll learn another simple example strategy, dynamic balance strategy. Let's go to the strategy editing page. And we will use the test strategy to edit here. What is a dynamic balance strategy? The dynamic balance strategy is a classic strategy. The basic idea of the dynamic balance strategy is to balance the money and objects held in our account dynamically. It can be simply understood that if the price of the subject matter we trade decreases, it means that the value of the subject matter decreases, but compared with the valuation currency we hold, that is, the value of money increases, we need to buy the subject matter with money, so that our assets can reach the balance of the value of money and the subject matter again. Similarly, if the value of the subject matter contract or specific currency we buy increases, it means that the value of the subject matter increases. And then, the relative value of the money decreases. At this time, we sell a part of the subject matter and then let the money and the subject matter reach a balance again. This is the basic principle of dynamic balance strategy. The balance strategy is actually similar to grid trading, which is also called wireless grid strategy on the internet, which is equivalent to doing a balance all the time. We will sell the subject matter, but not all of it will be sold. When we buy, we will not completely use up the assets to buy, which is equivalent to an unlimited grid. In fact, the strategy design is a relatively simple one in Python language. We can design this strategy together. The code is very short here. First, let's define two variables. We need to use the keyword var_ip to define variables. Why use the keyword var_ip to define variables here? This is because we need to use the tick model for dynamic balancing because we need to detect price changes at every moment. When the tick model is balanced, variables must be updated in real time, and it cannot be declared with the keyword var. If the keyword var is used for declaration, it will only modify the value when the current kline bar is finally submitted. We have also learned this in our previous courses. We use the keyword var_ip to declare a variable. The first variable is called balance. We use the function input to initialize it. We can initialize a value at view. Here we initialize it to 50,000. And we name it as balance. Then we use the keyword var_ip to declare another variable, stocks. Which is also initialized with the function input, and here we initialize it to 0. and we name it as stocks. So what are these two variables used for? These two variables are used to simulate the value of money and currency in our account, and then we can configure them according to our asset ratio during the backtesting of use. Of course, if we want to run it in a balanced state at the beginning, we need to configure it. For example, if the current currency is 100 yuan for each, we can set the currency to 1 and then set the balance to 100. At this time, the asset value of the subject matter and the value of the valuation currency as a transaction are in a balanced state. After setting these two parameters, let's set a more important parameter, max diff value. This parameter is a constant parameter, so we do not use the keyword var or var IP to declare it. What is the function of this parameter? When we make a dynamic balance strategy, the current price of the subject matter changes in real time, so the balance must be changing at any time. We cannot balance when the value of money and the value of the subject matter slightly deviate. It will be trading all the time, and the trading quantity may be very small, which cannot reach the minimum trading limit. Therefore, we need to specify an offset, that is, when the value of money and the value of the subject matter deviate to a certain extent, we will balance them. So in this place, we can declare a parameter, max diff value. And we initialize it to 1000. Also, we use input function. That is, when the value of our money and currency exceeds 1000. Of course, the 1000 is calculated according to the pricing currency. If the trading pair is set to ETH USDT, then the pricing currency is USDT, and 1000 means 1000 USDT. This parameter is also named as max diff value. After setting these three parameters, we can write the trading logic of the strategy directly. Oh, don't forget to name it as max diff value here. And then we can write the trading logic of the strategy directly. Balance is divided into two cases. The value of money is greater than the value of the subject matter, or the value of the subject matter is greater than the value of money. We first write the former one. If the value of balance is greater than the value of the subject matter we currently hold, we'll balance it and write a conditional structure with an if statement. Directly, if balance subtracts the built-in variable close. Close multiplied by stocks. if if it's greater than max diff value. We must judge it in the real-time bar stage because it cannot be treated in the historical K-line bar stage. Then we need to add a condition when it is in the real-time bar stage. That is, not bar state is history is false. Not bar state is history is false, so we can judge it. At this time, we can write more balance and open long on the comment, which means that the value of the balance is relatively greater than the value of the currency we hold. It's more balance open long. And it should be calculated according to the current price. It is greater than or beyond the range of 1,000 USDT or 1,000 pricing currency we set, and it is on the real-time bar stage. We open long positions. We can use the function of opening long positions we have learned before. Because our strategy does not specify a parameter position scaling in, we may go long or go short all the time because when the price has a unilateral trend, the value may always deviate in one direction, and we may go long or go short all the time. At this time, we can't use the function strategy entry to place an order. We should use the function strategy order. We have learned the function strategy order in the previous course, and we use the function strategy order to place an order on it. We name the order as long and classify it as a tag. Then how much should we buy and when we place an order? This needs to be calculated. We can declare a local variable trade amount. Then we assign the value of balance. We write it here, trade amount. Assign it the value of balance. Balance. Subtract close. Multiplied by stocks. Oh, don't forget brackets. We calculate the value of the actual deviation. We divide it by 2. And then divide it by clove. So that we can figure out how many subject matter to buy so that our assets can reach balance again. The calculation is very simple. It is to calculate the value of the current deviation, divide it by 2, and then divide it by the current price of the subject matter, so that we can figure out how much we need to buy to make it reach balance again. Here we calculate the quantity to buy. And then we can write it in the order function. We specify the order direction as long here. And then we pass in the trading volume, trade amount. After placing an order, we also need to update the balance. Because the previous 2 variables are used to record the balance status in real time, we need to update the balance variable and assign it a value. Here we use the assignment operator. To subtract the amount spent when buying. That is the number of transactions multiplied by the current price. And then reassign it to balance. That is, we updated how many numbers of balance left. At the same time, we also need to update the stocks. Similarly, we use the colon equal sign operator to update the stocks. We need to add trade amount here. After we updated the stocks and balance, we use the function runtime log to output some current information. We print balance. And then we print the stocks and trade amount. After we printed out the key information that we mainly use for observation, then we can continue to write the code. Of course, this is the long direction. If the price of the subject matter increases sharply, that is, when the value of the subject matter price is more than the value of our valuation currency, then we make a short position. We use else if here. Where we judge the other direction, we use close multiplied by stocks. Then we judge whether its minus balance is greater than max diff value. At this time, if so, and it is in the real-time K-bar stage currently, then we make a short position. Let's write a comment in this place. When the price value of the subject matter is too high, we let it open short. Similarly, we need to calculate the trade amount first and calculate the amount of transactions. The algorithm is the same as above. We multiply close by stocks. Then subtract balance. Then we divide it by 2. Then divide it by close. In this way, we can calculate the amount of transactions, that is, how many subject matters need to be traded when the balance is reached again. Then the balance between the value of the subject matter of the account and the value of the money can be reached again. Next, we still need to call a function strategy order. We set the tag as the short direction. and set the trading quantity as trade amount here. Then we need to update the balance and stocks after the transaction. We modify them with the assignment operator. We can copy from here and change it. At this time, balance is in a going short direction, which means selling the subject matter out. At this time, we need to use balance plus. The number of assets we obtained from selling, that is, trade amount multiplied by close, and because it is selling out, stocks should be subtract trade amount here. And then we use the function runtime log to print the relevant information, including balance, stocks, and trade amounts. Copy it and paste it. Oh, it may be we forget a space here. Here the space. Finally, we'll draw two lines on the chart to see the balance of assets. We use the function plot to draw the lines. And we name it as balance. Balance value. We draw the numerical state of balance on the chart for our observation and analysis. So here we name it as balance value. Quote currency. And then we set the color to red. This line represents the change status of the money in the account. We record it on each K line bar. Then we also record the change status of asset value of the subject matter. We can copy this line and change them. Here is stocks. We name it as stocks value, quote currency, and set the color to blue here. Oh, here stocks. It is multiplied by close. Don't forget it. This is the correct one. After the code is finished, we can conduct the backtest here. In the backtest page, we set the start time on 2021 March 1st. (0 o'clock), and set the end time at 2022 on September 8th. Also 0 o'clock. Apply. The time period, we set it to 1 hour here. Because I have backtest on this time range, I record the price at that time. We can set the balance of the parameters in the initial state. So we fixed the time range for backtesting. At the same time, we set the initial currency to be about 1,000. Then we set the initial rate to 3. And then set the equivalent value, that is 4374. At this time, the value of 3 currencies is about 4,374 USD. They are about the same amount at this time. At this time, we let the strategy start running in the initial equal state. And we choose Binance Exchange and set the trading pair to ETH USDT. And we click Backtest. Oh. Here we set is bar model. Because if we set the tick model, for backtesting, it will be very slow because each tick needs to execute the strategy logic, and the backtesting speed will be relatively slow. In order to save time, we use the bar model, and the results of backtesting are probably similar. In our log message column, we can see it reports an error here. Line 15, bar state is history. So let's go to our strategy editing page to correct it. Here, line 15, bar state, that's it. And after correcting it, we click backtest again. After the backtest, some market charts of the strategy and the chart changes of the position will be displayed, as well as the changes of the profit and loss curve of the strategy. Wait for a moment. It will be shown quickly. Here we can see in our chart. When the deviation of balance value and stocks value reaches a certain degree, a balance will be performed. After that, the values of these two lines are almost the same. Then if the deviation is triggered again to a certain degree, the balance will be performed again. Therefore, we can see that the position of each transaction is when the deviation of the blue line and the red line reaches a certain degree. The blue line and the red line are almost the same after the transaction. Which is a relatively easy way for observation when using the Pine language as a strategy. Whenever the deviation between the two assets reaches a certain degree, that is, the distance between the red line and the blue line reaches a certain degree, a balance will be carried out. After that, the value will tend to be consistent, which we can observe. Then we can take a look at our P&L chart here. That is to say, when this strategy runs for a long time, it is similar to a grid strategy. It is a volatile market for a long time. Generally speaking, it will continue to make profits. However, if it goes unilateral in a stage of the market, there may be a large floating loss in the short term. We must wait until the price reverses. Only by closing the position slowly can the floating losses be reversed and some profits will be generated. The balance strategy and grid strategy are similar, and both of them have some characteristics, but in the long run, on a large scale, it may have a relatively positive return, but there may also be some risks in some parts. Therefore, this strategy is generally suitable for spot operation. However, due to the liquidation mechanism of futures and the liquidation mechanism of control margin, our strategy may not be able to bear a certain floating loss, so our position will be liquidation. And there will be no subsequent returns, so we can see that the operation of our strategy, every time the strategy balance transaction is completed, it will print out a balance quantity and the stock's quantity after the transaction and print the trade amount of this transaction, that is, the order quantity of the transaction. We can see that each order quantity is different, and it will make a dynamic balance adjustment according to the deviation degree of our assets, and the order quantity is different each time. This lesson is a relatively simple dynamic balance strategy that we have explained. If you think our video tutorials are useful, don't forget to like, follow, and repost. Thank you all, and see you next time.